We talked earlier about evaluating question answering. If we have the answer to a factoid question, we can simply evaluate it by seeing if the factoid the system returns is the correct factoid. Now, summaries can't be evaluated that way because we can't have a single perfect summary for any document. So we'll introduce a different algorithm called ROUGE. ROUGE stands for Recall-Oriented Understudy for Gisting Evaluation, proposed by Lin and Hovey. And here's the idea. It's an intrinsic metric for evaluating summaries. We're going to ask, is this summary good as a summary? Not in some other extrinsic application, but just as a summary. And it's based on a metric called BLEU that defined originally for machine translation. And it's not as good, ROUGE is not as good as using humans to say, did this summary answer the user's question? So if we can afford that, we'll certainly hire users and have them test to see if an answer answers a user's question. But ROUGE is very convenient for testing while we're building our system. And it works as follows. We're given a document D, and let's say we've got our summarizer, and it produces an automatic summary. And this can be a query-focused summary, so maybe we also know about the query that the user asked, or even for generic summarization. Now we have N humans produce a set of reference summaries of this document. Again, in query-focused summarization, they look at the query and write their summaries. In generic summarization, they just write their summaries. So we have a set of summaries, 1, 2, 3, 4 human summaries of our document D. And now the system produces another summary, call that X. So we have our automatic summary and our 4 human summaries. And now we just ask, what percentage of the bigrams from these human summaries occur in X? Obviously, they won't all occur in X. A good summary will contain a lot of the bigrams that occur in some of these human summaries. So by counting the percentage, we get an intuition for what's a good summary. And there are various versions of ROUGE, unigram ROUGE, bigram ROUGE. There's also other versions that talk about length in different ways. We'll introduce just one, ROUGE 2, bigram ROUGE, which works pretty well. And it's just asking, out of all the bigrams, in all the sentences, in all the reference summaries, take the count of those bigrams. And now out of all those bigrams, look at, again, in each sentence, in the summary, for each bigram, ask what's its minimum count in the summary produced by our system and the human summary. So it's asking how many bigrams occurred both in our system and in the human summary. So that'll give us, out of all bigrams, how many occurred both in the summary and in the human references. Let's look at an example. Here I've made up 3 human summaries and a system summary. So here's our human 3 summaries and our system answer to a question. Let's compute ROUGE. So the numerator, we want to know how many bigrams that occurred in these human summaries, how many of those bigrams also occur in our system answer. So we can walk through. Well, water spinach, that's in our answer. Here it is here. And spinach is, and is a. And in this summary, water spinach and spinach is and is a. And in this third summary, again, water spinach and spinach is and is a. But also commonly eaten and leaf vegetable and of Asia. So if we add all that together, we have 3 from this first summary and 3 from the second summary and 6 from the third. And how many total bigrams are there in the human summary? Well, you can count them yourself. There's 10 in the first example up here, 9 in here, 9 in here. So we have 3 plus 3 plus 6 over 10 plus 9 plus 9, or a ROUGE score of 0.43. So we've introduced ROUGE, an algorithm for evaluating summaries, whether they're generic or query-focused, by looking at how many of the bigrams, or n-grams in general, in a human summary occur in our machine-generated summary. And a better summary is one that overlaps more with the human summary. Now, ROUGE doesn't work as well as having humans actually answer the question, did this answer provide the information the user asked for? But that can be very expensive. And so ROUGE can provide a fast to run and convenient intrinsic metric that we can use to test our systems, and then at the end we can use humans to see how well they really did.